Good morning, Devoxx Ukraine. First of all, congratulations for this great conference. It has been 2 years since I've been here for the last time. It is always nice to come back. And today I'll be able to talk about one of my favorite subjects in the Java language space, which is the Effective Java book. So I'd like to start with a very simple question. How many of you have read any edition of the Effective Java book? Okay, a great amount. How many of you have read the third edition? Okay, quite some. Okay, and today we're going to revisit some best practices from the Effective Java book, some of my favorites, some of the new additions that were made to the third edition of the book. And first, some fun facts about me. First, my Twitter handle is @Yanaga. Just in case you want to follow me, of course, I discuss Java, DevOps, microservices, and other stuff. I'm also Brazilian Japanese. I'm 100% Japanese, but I was born and raised in Brazil. As they mentioned, also I'm a Java champion, Microsoft VP, and the DevConf Rockstar. And I've published this book for O'Reilly approximately 3 years ago about migrating to microservices databases, which appears to be still a very popular theme. So if you want to get a free copy of the book, you can go to this URL or to my Twitter profile. You can find a free PDF, EPUB or MOBI version of the book to download. And of course, I mentioned the Effective Java 3rd edition, and I think this Effective Java book was one of the most important books in my career because it's one of the books that makes you humble. So whenever you reach a certain point in your career, you think that you know everything about what you're doing, about Java, for example, about programming, then you read the book and you realize that, well, you really don't know nothing. There's a lot of things that you have to learn to progress in your career, and maybe learning Effective Java is one of the things that will help you move from being an engineer to become a senior engineer or a principal engineer or something. And I also liked to see how some great concepts, how they are spread together in other great books. For example, a lot of the immutability things, minimize immutability, are also a great match for other concepts from another great book, Domain-Driven Design by Eric Evans. So you see, great minds usually think alike. Some great concepts are widespread in our technology field. So let's see what we can try to learn today. Or even if you learn already, how can we revisit some great concepts from these great books? And what is new in the third edition of the book? We learned that we had additional sections about Lambdas, Java streams, optionals, default methods and interfaces, try with resources. And of course, I can't cover everything that is new on the book in just like 1 hour. But I don't want to tease everything. But of course, after this session, I hope everybody is encouraged to go and read the book because it will be a great addition to your career. Okay, so some of my favorites, I'll try to cover some today. We're discussing Effective Java, factory methods, try with resources, equals, hashcode to string, comparable. If you're wondering what are these numbers in front of each one of these topics, these are the sections in the book. So the book is like a guide for you. So if you want to really know about something that you need to do in your daily coding. Effective Java is one of the books that I always keep in my library close to me because whenever I'm in doubt, for example, serialization is a very complicated subject and nobody really knows how to do it properly without like any external resources. So whenever I have to code some serialization stuff, I always go back, open the book on the serialization part, read it again. Oh, maybe now I know I can try to do serialization properly. So these are the numbers, also minimize mutability and enums. We'll try to cover some of them today. And since we're talking about Java and Effective Java, just, well, doing slides is boring, so let's try to do some coding and see how it works. And of course, doing live coding is always tricky. Let's hope that everything works well today. And first, let's try to create a class. And creating a class, I'll start with a plain, if you use it to domain-driven design terminology, I'm trying to create a value object. And in my opinion, one of the hardest bugs to try to find and solve in our daily programming activities is the ones that are caused by inconsistent state. And the problem is that usually we design our classes with many getters and setters, so we have a lot of area to cover, we have a lot of mutable area, and whenever our system gets into an inconsistent state, it's very hard to tackle what was the point, what was the piece of code that caused that inconsistent state. For example, you have a variable, you get a null pointer exception, it was supposed to be never null, but you have that null pointer exception in production. So how do you tackle that? Well, that number was supposed to never be negative, but it is. So it's very hard for you to try to find and solve inconsistent state bugs in production. And one of the ways to try to avoid these kind of bugs is to make your code immutable. And we know because of the Java frameworks that we use these days, some frameworks require the Java Bean specification, for example, with getters and setters. If we can't make our code immutable, we should try to minimize mutability, okay? So, but let's try to do this class immutable at first. So I have a phone number. If I want to make these properties immutable, the easiest way would probably declare this field as final. So suppose that I have a phone number, oops, and I have an area code, and then I have, for example, final int the proper number. And since it's private, I need to initialize these numbers in a constructor, and if I generate a constructors. Okay, is this code immutable? Well, not that much. If I wanted this class to be immutable, probably I would have to declare this as a final class, but some frameworks don't work that well with final classes. So the easiest way for me to declare this phone number as immutable class, if I want to hide information, here I would declare this as a private constructor. Because if it's a private constructor, even if I subclass that, nobody will be able to instantiate instance of phone number, so it should be safe for us to declare this as a private constructor. And actually, it's very nice because if I leave here, most of the IDEs these days can refactor this constructor to another very nice way of creating a class, which is with a factory method. So if I declare a private constructor and I just declare a public static method called a factory method that I create instance, I have another benefit of effective Java book. For example, what is the benefit of creating a factory method instead of just creating constructors? First, it's a matter of taste. I think that like constructor knew something is one of the ugliest parts of the Java language syntax, so having to declare new. So maybe if you prepare methods, you will prefer a static factory method like this one. And another benefit of factory methods is that factory methods have a name. For example, on this particular method, I called it off, but some other common names in the Java language are, for example, value off. You can find that on the JDK. If you know that you're always creating a new instance of your object every time you call a factory method, you could, for example, call it new instance. I know that I'm always returning the same instance, but if you don't want to be tied to always creating a new instance of your object, you can call it something like, for example, off. Let's try to stick with off, and whenever you're trying to create an object, rather than dealing with validation and inconsistency in state later, you should always try to validate the invariants of your code whenever you're trying to create your object. For example, whenever I have this phone number off and I receive an area code and number, I should validate them. Suppose the area code should always be greater than 100, so I could, for example, use an argument, check argument, area code greater than 100. And if you're wondering where does this method come from, I'm using Google Guava, and I know some people have mixed reactions about that because of incompatibility issues in the past. But even if you don't like Guava, you could use like any other library, Commons Lang and other libraries. But if you look at this implementation of this method, it's pretty simple. For example, check arguments, just if not expression, throw new illegal argument exception, which is the proper exception that you should be throwing if that's an illegal argument that you're receiving. So going back here to my code, I just check the argument. Well, the error code should be greater than 100, and maybe the number should be greater than 1,000. So if I receive here, number should be greater than 1,000, and we should be good. Then, if I had the invariants, if you had other invariants, you should be adding here whenever you're trying to produce an object. And if everything went well, you can return a new instance of your phone number. You have the guarantee that whenever you have a phone number instance in memory in your application, it will be a valid instance of phone number. Okay, so that's first. What is the benefits of using a factor method in this case? Well, first, you are not required to always return a new instance of phone number. Suppose, for example, the phone number requires a very complicated computation, or maybe you will need to access a database or something, or check other things that requires a lot of time. If you're using a factor method, you can return always the same instance. For example, I could create an internal cache, an in-memory cache, and I could cache, for example, I already created a phone number that has an area code like 200 and a number like 2000. So whenever I receive the same arguments in these factor methods, I can always return the same instance. So you're going to save memory in production, and you're always also going to save time whenever you're trying to return a new instance, an instance of phone number with this exactly same arguments. And if you're always returning the same instance, if you're implementing the fly-wave design pattern, for example, you have the added benefit that you can compare different instances of phone number using the equals operator instead of using the equals method. So it's even faster because it's always the same instance. So, and another benefit of caching, for example, if you want to see a very nice implementation of the fly-wave design pattern, you can look at, for example, in the JDK, the big decimal class, you have the fly-wave pattern between values of -128 and +127. All of these values are cached, so you can compare instances of big decimals using the equals operator if you're comparing numbers within that range. Because supposedly, it's very common for you to be using numbers on that range. If you use a factor method too, you can delegate the decision of which type of object you are creating to your factor method. Suppose that, for example, my API is going to evolve, and today I only need a phone number. But some months or years later, somebody decided that our system now needs to deal with phone number in a different way, if it's a local phone number or if it's an international phone number. So maybe I would create like 2 different subclasses, phone number, local, and international phone number. And now I just realized that all the area codes that are greater than 500 are international phone numbers. All the area codes that are lower than that are local phone numbers. And if I didn't use a factor method, if I just decide to use constructors, you would have to go and search through your entire code base. Whenever you were issuing a new phone number, now you would have to go there and check, is this phone number that I'm creating now an international phone number or a local phone number? So you would need to scatter this logic of which type of instance you would have to create across your entire code base, because you fixed the type that you were creating when you use a constructor, new phone number or new international phone number or new local phone number. But if you decided to use a factor method, it's just a matter of changing the implementation of your factor method. You could say that, well, if the area code is greater than 500, then you should return a new international phone number. If I had created this class, this hierarchy. Okay, so a factor method allows you to evolve your API much easier later. And if you decide that a phone number shouldn't be a class, it should be an interface, for example. Now that with Java 8+, we have static methods in interfaces too, it's even easier because your API will remain the same even if you change this class to an interface later. So it's a great addition to the Java language. It's another benefit of using factor methods. When should I use factor methods? For example, here my factor method has only 2 arguments. But if you have a lot of internal state, which could be a code smell, for example, having a lot of internal state could be a code smell. Maybe you should be splitting your class in multiple smaller classes. But suppose that here you would have like the factor method with 3 or 4 arguments, which again becomes another code smell. Maybe if you have like a lot of parameters in your fact method, you could use another pattern for creating instances, which is a builder. Yeah? I won't be able to cover builder today, but it's a common question. Well, what if the number of arguments in my factor method keeps growing? Now, well, then in this case, maybe you should create a builder. Okay? And here, if I have a value object and I have a factor method, maybe I want to implement also the equals and hashcode methods. So suppose that I want to implement equals, and a nice implementation of equals, for example, could be if object instance of phone number return objects.equals, and Guava provided this method before, but since Java 7 Plus, I have this method in the JDK, so I can do Java objects equals, and I can compare these area codes, other, oh, I forgot to make a cast here. I can say phone number, other receives object, and I fix it, and other.area codes, and object.equals, this dot number, and other.number. Okay, and just in case, return false. So this is a nice implementation of an equals method that respects the properties of equals methods in the Java language. They should be transitive, they should be symmetric, and they should be reflexive. So it matches all of the properties that we have. So it's a nice implementation in this case if you don't care about performance. What is the problem with this this implementation? Objects.equals, you should only be using this method if you're comparing object references, because object equals, they deals with the logic between, oh, is the first argument null, is the second argument null, are both null, or are both null? So all of this like problematic logic is dealt with if you're using object equals, but here we know that area code, for example, is a primitive value. And if you decide to use object.equals, you pass in a primitive a value, we're performing boxing and unboxing, which is an expensive operation in the JVM. So in this particular case, instead of using the object equals method, we should be using the equality operator. And now I'll just leave the other one as objects equal, just for you to know that you have two different ways of doing that. And another very quick optimization that we could be performing in the object equals method, the equals method, is that if we know that our object is being frequently being compared to itself, for example, if you have a collection, if you have a set, a list, or something like that, and you're always using the method contains, does my collection contains this particular object? A very cheap optimization would be to add this, if object equals to this, return true. So it's a very quick one-liner optimization, and it will speed up your optimizations if you're constantly using the contains methods or comparing this object to itself. So I have equals methods. Whenever I implement equals, I should always be implementing hashcodes. And you know, some people forget about that. I wasn't aware of that in the beginning of my career. So I got a lot of bugs using hashcodes and hash maps because we were implementing hashcode. But the fact is that our objects weren't immutable. So whenever you're trying to use an object as a key to a hash map, for example, or in a hash set, you should make sure that at least the values that you're using in your hash code are immutable. Because you used to be in the past, I used to have like a code. We would have a hash map, you would create an object, you would add it to the hash map, and some like 10 lines later, you would ask the hash map, does this hash map contains this particular object? And it would return false. But I just added this object like 10 lines before. Well, what happened in between adding and queuing the hash map for, does this hash map contains this particular object? Well, I changed the values of my object, and of course the hash code changed too. So it would be an inconsistent operation if your hash code is not constant, or at least if the values that you're using to compute your hash code, if they don't change over time. So they should be tried to as immutable as possible. And one implementation that you could be possibly doing, for example, this hash code, you could be, again, if you're using Java 8 Plus, you could, Java 7 Plus. You could say this area code and this dot number, and the contract also requires that if you're using, you should use all of the properties that you use in your equals in the same order for you to compute your hash code. So object.hash, area code, and number, this should be a very nice implementation of hash code. Again, if you don't care about performance. Because what's the issue here? The issue that we learned that here I'm receiving a var args of objects, which means that I have to box area code and number for this method to be executed. And also it's a var args. So I have one of the worst possible practices. Creating an array in Java language is one of the most expensive operations in JVM. So here I'm creating an array every time, and I'm also boxing. So this is a very slow implementation of hash code. You could also, for example, use your IDE to generate your hash code for you, which could be a very nice implementation. You can read the book. Josh Bloch provides you a very nice implementation of hash code. In the book, you could also use another library. For example, you could use Lombok. about that. I don't use Lombok in my daily code, but that's just a matter of taste. So I prefer to code myself. But if you know that your properties are immutable, for example, your object is immutable, my properties are immutable, and even though it's an expensive operation, I can pay the price of executing this method only once. You could, for example, say that let's try to declare this in another property. So I could say hashcode here, and this dot hashcode could be objects.hash area code, this dot number. So instead of returning and computing this every time, I can just return the hash code. So this is another possible optimization that we could be executing in our hash code. Another method that we should always be implementing in our objects, in this particular value object, business objects, is the toString method. And some people believe that toString should be a business string. No, toString is a string for you as a developer to understand what is happening with your code. Because whenever you're debugging your code and you want to get your mouse over that particular object, you want to know, well, what does this object represent? What is the toString method? What is the instance? What is the internal state? Or if you're using this object in a login statement, you want to understand what was the state that caused that particular log statement. So toString is a developer string, and one nice way for you to create a string, of course you have multiple different libraries. I think that Guava's more objects toString helper helps us to create a very nice implementation. So I could say that area code here, this is the area code, add number, and also this dot number, and I can say about toString. So if you want to know how does this toString method print, we can say, well, let's associate a new phone number, saying 200 and 2000, and print it. So if I just try to execute this main method, you see the phone number. I know the instance type, which in this case is phone number, area code 200, and number also equals to 2000. And you might be wondering, this is a very nice implementation of toString, but what about my business strings? How do I print this phone number as something that should be shown to the user, for example? Well, most people aren't aware of this particular interface, but it has been available since Java 6 Plus, I guess. And the proper way for you to be printing your business strings is using the formattable interface. The formattable interface only has one single method, which is format to. And suppose that my business requirement here is that the area code should be split by the number with a single dash. So I could say, well, I could say formatter, format, and print this digit dash another digit, and I'm passing the area code and also the number. And how does it differ from my print ln statement? I could say print f, which in this case I'm using a formatter. I'm passing that as a string. And you can see phone number, this is the toString method, and this is the business string that should be printed whenever I need to show something to the user. Oh, and I have another point here. Whenever you're showing in a string different properties of your internal state, for example, 200 and 2000, you should also provide getters for these properties in your code. For get area code and get number, I advocate against using like automatically adding the getters and setters into your code. In this particular code, the phone number is immutable, so you would only need to provide getters. But since I'm printing this string with separate area code and numbers, I need to provide the getters for that too. Right? And why is that? Because we know if you're showing this thing separately in a pre-printed string, somebody will say, well, now I need to get these values separately. And we know developers are super smart, and you know that if you don't provide the getters and setters, the developers will know, oh, the business string has the values already separate. So what would a developer do? I would get the business string, I would parse that, I would split by the dash, and I would know that the first argument is the area code, and the second one is the number, right? But later, somebody decides to change the business requirements, and now you don't have a dash anymore. You have a parenthesis, you have a space, and you have the number. And all the code that was parsing that string now is broken, and it's not type safe, it's a string-based development. Well, you can see the problems that will happen in your code base if you decide to change the way that you format your business string. That's why you should always provide the getters and setters for your code, okay? Another addition, suppose the phone number should be comparable, because sometimes you need to order the phone number. And if I want to implement the comparable, to make it comparable, I need to implement the comparable interface, and it will give me the compare to methods. And before Java 8, if you're using Guava, for example, a nice way for me to be comparing this, implementing comparable would be, well, let's first compare this area code and all that area code. This dot number, O dot number, and result. Okay? And comparison chain, whenever I have this comparison and it already is different than 0, for example, it will return the result already, because if it's different, I don't care about comparing the other numbers. But if you're using Java 8+, you don't need to rely on Guava, for example, to implement compare to. We have another implementation which is even better than this one. For if you're using Java 8+, you can use Lambdas to create your comparator. So let's try it with comparator and comparing. Since I know it's a primitive value, I can use comparing int. And since I can phone number P, and I can say, well, let's just compare both phone numbers. And then comparing int, I can say, well, just compare P dot, oh, actually it's the opposite. I first compare the area code, and then the number. And after this, I just compare my object with the other one. So I'm comparing, what I'm doing, I'm creating a new comparator, and after I created the comparator using the area code and the number, I can compare this object with the one that I'm receiving as an argument. And I can use return here. I just comment out so you can see later. You can use both implementations. And again, this is a very nice implementation if you don't care about performance. Because every time I'm invoking this method, I'm creating a new comparator instance. So what can we do? Well, maybe we can refactor again and extract a constant. Because I could say phone number comparator, they are thread safe. I can reuse this instance over time. Phone number dot compare this dot o, and I have this field here, my comparator that is being instantiated only once. It doesn't even need to be public. It could be a private statement. Okay, so it's a very nice way to implement comparator, and these are some of the tips that I have. Some are old, some are new. For example, using comparators here is new. If you want to use some of the sections of the effective Java for yourself. What can we do now? Well, let's try to add some more features here. For example, with Java 8, we have Lambdas, and of course, if I want to use a Lambda, I need a functional interface for that. And whenever you're using functional interfaces, also we have another gift from here for Java. If you have Lambdas and we have functional interfaces, now we can favor the strategy design pattern instead of using the traditional template methods. Let's try to use that. Okay, so if we're trying to use in our code functional interface, for example, suppose that I want to create a new Java class here. I want to create my new functional interface. New functional interface, and I have 4 here. My function interface. If you want to declare your own function interface in Java, the requirement is that your interface should have only one abstract method. And I could say for a public void, do something, which is a very bad interface because it has a very bad method. When you say public void do something, you have a method that receives nothing and returns nothing, which means that the only thing that this interface can cause is side effects, right? You're changing the internal state of your object with another internal state you already have. So this is a very bad interface, but I want to do that, well, for instructional purposes. If you're creating your own function interface, you should always add the annotation add function interface. And why is that? Because if you add another method, here is not a function interface anymore. And you might be wondering, I'm a very great developer. I know that this is a function interface. I'll never change this later. Well, somebody, 1 month, 6 months later, might decide that, well, have this interface, would be nice if we would add another method. They just decide to add this method, and even worse, you're not using this function interface in your own code. You're using this function interface as a library. You're designing a library, and this library is being used by other projects. Well, you added another method in your interface. Your library still compiles, but whenever people start to update their libraries, they'll have like, doesn't compile anymore because you are using this interface in Lambdas and, well, it's not a function interface anymore. But if you decided to add this annotation in your code, add function interface, your future self, maybe, whenever you try to add another method, the compiler will argue, well, you designed this interface as a function interface. You can't add another abstract method, okay? But this is if you really want to add a function interface in your code. Most of the time, you shouldn't be adding function interface in your code. And why is that? First, the JDK already has a lot of function interfaces. And I think you have these days you have more than 40 function interfaces in the JDK, and it covers most of the business case that you need to implement. So why adding another function interface for your code? Well, it just is another interface for developers. Your colleagues need to learn to be able to use your code base. Okay, so but do I need to remember or by heart all of the functions interface that I have in the JDK, more than 40? Well, not really. If you just learn this 6 function interface in JDK, you'll probably be able to cover 99% of your uses of our function interface. And what are that? You have unary operator, binary operator, predicate, function, supplier, and consumer. And how do they work? Unary operator is an interface that receives one argument of type T and returns the same type T. So I receive one argument, return an argument, same type. Binary operator, I receive 2 arguments of the same type and return the same type T. A predicate, I receive an argument of type T and return either true or false. A function is something that converts one type to another. So I receive a type T and return type R. Whenever you're using a stream with a map operation, for example, you need a function. You need to map an object type from A to B. A supplier is something that, well, receives nothing as an argument and creates something for you. If you have a random number generator, for example, you might implement that as a supplier because, well, you require no arguments and you're always returning a new instance. And a consumer is something that receives something, a type T, and returns nothing. Consumer operations are the one, for example, if you're doing system.out.println, this is clearly a consumer operation because you're receiving something and you're sending it to somewhere. You have a socket operation too. It also could be a consumer. So, and what are the, well, but you said that there are more than 40 function interfaces in JDK. What are the other ones? Well, in Java, we need special interfaces for object references, which are this one, but we also need the variants for primitive types because of performance. So you have unary operator, you have int unary operator, you have long unary operator, you have float, you have double. So you see most of the variants of the function interfaces are just variants for primitive types. So if you learn the 6 different types, you'll be able to cover most of the business use cases in your application, okay? So I have these function interfaces, and if I go back here to my code, I said that with function interfaces, we should be favoring the strategy design pattern instead of the template method design pattern. How does it work? Well, suppose that I want to create a new class here. It's going to be my template logic. And I create that. So I have my template logic here. And in the past, if I had a set of common operations that I would need to perform before and after something, but the middle of the operation would be different between like different implementations, the way that I would do that, well, public void do something, and I would say that, well, maybe I need to implement a very complicated business logic for this, for example. Then I would do other thing. Then I would have another very complicated business logic here. So do other things should be implemented public abstract void do other thing. And this class will need to be implemented as an abstract class. So you know we had these operations here. I would need to perform a database validation, and here I would need to update the object and send to another thing. Well, you guess it's a complicated business operation, but I want to have different types because depending on what I want, the implementation, I want to change this other thing here. And the way that I would do this, well, class simple business logic, extends my template logic. And I wouldn't just need to implement the other thing, and I would say, well, this is a template method implementation. So the other thing is my template method, and I need to subclass this to be able to implement that. This is the old style. Before Java 8, this would be the recommended approach if you wanted to implement something as this. I have something that should be done before and after, but I want to change what is done in between. So since Java 8 Plus, the way for me to perform the exactly same operation would be using the strategy method, the strategy design pattern. And how does it work? So what is my strategy logic? And here let's create it as a class, for example. And I declare the same method, do something. And here I have my complicated business logic. And here I also have my other complicated business logic, and I have something in between. So how do I call the method in between? Instead of creating an abstract method, now I can receive this as an argument. For example, if let's try to use one of the function interfaces here. I want to use a consumer of string, and a consumer. Since I'm creating that, I need to generate a constructor. And since I'm generating a constructor, let's try to use the best practices, refactor method auth. So instead of doing this, I could say, well, now you can print this and say consumer.get. Oops. Consumer. Oh, sorry, wrong class. It's not a consumer, it's a supplier because I want to receive a string. I want to use a supplier and consumer.get. Yeah, let's refactor this as a supplier too. Yes, please. Luckily, we have very nice IDEs these days that can refactor for us. So what is the strategy here? Well, the strategy is that supplier.get, I don't need to create a hierarchy of classes. I just need this class because the operation that varies, I can provide on this method as a Lambda reference. For example, let's try to use this in runtime. If I have a main method here, I could say, well, I have my strategy logic of my strategy logic, and I provide a supplier. Let's provide a Lambda saying it could be like Devoxx Ukraine. And whenever I do this, it's going to do something and do something. So if I just decide to run this method, you see that I'll print the logic before, Devoxx Ukraine, NMB, and whenever I need to change something, let's say, instead of Devoxx Ukraine, just Ukraine. I have a different implementation, so I'm changing the implementation, passing a Lambda as an argument, okay? So here, Devoxx Ukraine, here I have Ukraine. That's the way, now that we have Lambdas, you should usually favor strategy instead of template methods. That's one of the additions. And you might be arguing, well, you just can't pass like this very simple business logic because it's a one-liner. Well, not exactly. It can be a one-liner, but it also could be a reference method pointing to a method that has like a very big, complicated business logic. So since we're talking about lambdas and factor methods, lambdas and method references, we need to learn more about these types of method reference. And you know, method reference are very nice synthetic sugars, so instead of using a lambda, in some use cases you could be using a method reference. And how does it work? Let's go back here to my code. Method references, and in Java, we have Java 8 Plus, we have 5 different types of method reference, which, as I said before, in some use cases, it's a synthetic sugar for using, instead of using a lambda, you can use a method reference. And what are the different types of method reference that we have in the Java language? For example, the first one is the simplest possible one, is the static method reference. Suppose here that I have a method, and this particular method, it requires a function, saying that I need to receive a string and convert that to an integer. So what can I do? Well, if it were a lambda, I would return and receive a string. I need to convert that to an integer. So maybe I could say integer.parseInt s. So yes, it's a lambda, a very nice lambda, but it could be easier. I could replace that, and most IDEs these days, they refactor automatic to method reference in most of the cases. I replaced this lambda with a method reference. So now I have integer, colon, parse int. And it's a static method reference because, well, parse int is a static method on the integer class. Okay, so this is the simplest possible one. And now let's show you the most complicated one, which is the bounded method reference. So static, the simplest one, most complicated one, the bounded one. So in the bounded method reference, here I have a predicate of type instance. So I need to return, I'm receiving an instant as an argument, and I need to return either true or false. And just in case you're wondering, I'm using the exactly same code examples as you have in the book. So here I'm receiving an instance, as in the Lambda I want to use, well, I want to call the instant class, I want to call this method now. This method now is returning a new instance for me, and on this particular instance, I want to call the method isAfter and pass this object as an argument, so instance. So this is a Lambda, instant.now isAfter. How do I refactor this to a method reference? Instead of doing that, I could say instance.now, colon, isAfter. And you might be wondering why it didn't refactor automatically for me, because these two different implementations are not bytecode equivalent, okay? Maybe you could have another one, but this particular example, they are not bytecode equivalent. But what is happening in this method reference? I have this class, I'm calling this method, I'm returning an instance, an object instance, and the instance that is being returned, I want to call this method isAfter. This is the most complicated one, and to be very honest, I've only used this type of method reference when doing this kind of demo. I didn't use that in real-world applications yet, but you know, maybe it will happen one day. And next one, unbounded method reference. Here I have a unary operator which receives a string and returns a string. One possible implementation, I have a string, and in return this string as a lowercase. If I refactor this, string colon to lowercase. Okay. I have an unbound method reference. I also have the constructor method reference. So here I have a supplier, which means that I received nothing and I need to return something. So, and I need to return a new tree map. So if I receive nothing, it's an empty lambda, and I return new tree map. Okay, and if I want to refactor that as a method reference, I just go back here and replace lambda, tree map, colon, new. This is the method reference if you want to use constructor method reference. And the last one is an array method reference. Here I have a function which receives an integer and is returned as an array of int. So I receive an integer and I return a new array of type int. If I want to refactor this as a method reference, well, int, brackets, colon, new, I'm returning a new array. So these are the 5 different types of method reference that you have in the Java language, and you might argue most of the times using a method reference represents a simpler syntax after you learned rather than using a lambda. So you just need to get used to the syntax when you shouldn't be using a method reference. For example, there are some cases where you have like some very big, complicated like class names, and maybe like, for example, declaring the class name is going to make you type like 50 different characters. If you're using like, it happened to me in the past, for example, if you're using Spring Adapter Factory being something, you have a very big method, maybe then in this particular case would be better to use a lambda. But again, works what makes sense to you. Use what makes sense to you. And these are the different types of method references. What else can we use? I want to show you to use some lambda as a method reference, and I also want to use one of my favorite features of the Java language, which is enums. For example, with enums, if I want to create a singleton, the best way for you, I already have a singleton. I already have it implemented here. So I have a singleton. The best way, the easiest way for you to create a singleton in the Java language is to create an enum. public enum singleton, and you just declare a single instance. So the old pattern of declaring like a static field, public static something instance, and a get instance method returning the proper instance. Well, this is old-fashioned, and it doesn't work if you use serialization, because every time you deserialize that, you will have a new instance, so you will need to create your serialization proxies or something like that. If you want to create a true singleton in the Java language, you need to use this pattern using the enum as a singleton. And you know, enums are not like simple, like, well, a fixed set of instances. Enums are full-featured classes. And if you show this kind of code, for example, for a C# developer, he or she would be very jealous because in other languages, C# for example, enums are just a syntactic sugar for declaring constants. But in Java, you can add methods, you can add fields, you can have states, you can have polymorphic enums. And that's one of the best features of the Java language, that when I read the second edition of the Effective Java book, I read that particular section on the weekend, and the first thing I did Monday morning was to show off my colleagues that, oh, look what you can do with enums. And that's what I'm going to show you today. And they said, oh my God, that's amazing. How do you know so much? Well, I just know. Yeah, kidding. Well, I just read the book in the language that I wanted to brag with my colleagues. But you know, if you read the Effective Java book, you might have some bragging rights later when you're working with your colleagues. So in EnumWave, you can have polymorphic enums. And if you're using pre-Java 8 syntax, the best way for you to create a polymorphic enum would be this way. So suppose that I want to type here operation add and subtract. Okay? I could also implement, for example, multiply and divide. And I want this to be polymorphic. So what do? I create a method for public int compute int x and int y. And this method, instead of providing the implementation, oh, in this particular case, it should be abstract. And since it's abstract, I could say I can implement these methods into each one of my instances. For example, x plus y. If I have a subtract operation, it could be x minus y, deny for now, yeah. And compute, and here divide, I could say compute divided by y. So it's a very nice way for you to create a polymorphic enum. And if you show this code to your colleagues in the past, they would be very amazed because, oh, you mean that whenever you're declaring an enum, you can extend it at the same time, so you can have like different implementations here? Yes. And you might argue that, well, I don't know if it's readable, but you can see it's very powerful because you have polymorphic enums. This is the best way for you to do this kind of thing before Java 8. Now with Java 8, remember, instead of using this kind of implementation, the best way for me to use these polymorphic implementations is using the strategy design pattern. And how do I do that with the strategy design pattern? Well, I can declare fields also if I'm using enums. I could say final, and I can use an int binary operator because I'm receiving two ints and returning an int 2. I have this one, and since it's a final field, I need a constructor. Since I'm using a constructor, and this method doesn't need to be abstract anymore. I could say compute could just return operator apply as int x and y. And how does my implementation look like now? Well, I don't need to be implementing here anymore. I just need to pass an argument in my constructor. So here I'm receiving two, since it's a binary operator, two arguments, x and y, and return x plus y. Subtract again, I can replace this with x, y, returns x minus y. And again, replace the multiply, y, x times y, and divide, I here, divided by y. Okay, so we might argue that this syntax is much easier to read. You have much fewer lines of code. It might be a better implementation. And the argument again comes because I've did that in the past with some of my colleagues, some of my teammates. They said, well, you can only do this because your operations are super simple. Like it's a one-liner again. But suppose that you want to do this as a business operation and the implementation of your strategy is a very complicated one. Maybe this would consume like 10 or 15 lines of code, or maybe you would need to decompose this in multiple smaller operations. How can I do that and still keep this polymorphic enum? So what could I do is that instead of operation add, I could, for example, create a class called sum, and let's try to public static int, and I receive x, and I receive y too. And suppose that I would have a very complicated business operation here, and then in the end I would have to return x plus y. So this is a very complicated business logic. I have a lots of line. It wouldn't fit in a Lambda. It wouldn't be readable if I did that in a Lambda. But since I did just that, I can go back here to my operation enum and say, well, instead of using this single liner Lambda, I could say, I could pass this sum colon at methods. See, I'm using a method reference instead of a Lambda because the code is big, but I implemented the business logic in a plain old static methods, and now I can keep reusing this thing, okay? So that's one of the very nice use cases where you can have like this operation and use a method reference to simplify or to enable your enum to be even more powerful. All right, and I guess these are the tips that I had to show you with you today. And of course, this is the tips that I have for Effective Java. Later today at 4:20, room 6, I have another session where I'll be talking about Quarkus, which is a framework that in the Java space is sparking joy in everybody these days. So if you want to learn more, I have another session today too. And thank you very much for now. And if you have any questions, I'm available.